Hey guys, welcome to Neuraltic Analytics. In today's advanced SQL data analysis class, we'll discuss about Windows functions. So Windows functions are very useful and they are highly used in the data analytics. So let's discuss about the Windows functions. So what exactly are Windows functions? Windows functions perform calculations across the set of table rows while keeping the original rows intact. That means it does not changes the rows. Okay, Windows function does not collapse the rows. It's only add computed columns. It will create a new computed columns. It won't change the number of rows a table has. Okay, that's very important. So where exactly we use Windows functions? Normally, when we want to kind of calculate maybe running totals like cumulative totals or rankings or any kind of moving averages, in all those cases, moving averages. So in these kind of cases, we use Windows function. Okay, and also a lot of time when you want to compare this year sales with last year sales, or sometime analyzing the trend in those kind of areas, also in those kind of analysis also we use Windows functions. So let's talk about the first window function, which is the first Windows function today we'll discuss is row number. So row number function assigns a unique integer to each row within a particular partition. The numbering starts from 1 for the first row in each partition. If there is no partition by clause, then it will treat the entire result set as a single partition. Okay. So basically it will assign a integer number. So let's say we have a table called employee, select star from employee. Okay, this is one of our table. Now I want to assign a row to I want to assign a number to each rows of this particular table. So how I can do that? I will use a row number function. Select star, then I am going to use a row number function. So how to use Windows function? The syntax is very simple. You have to use that particular function and write a over clause. In over, either I can use the order by, let's say I want to order by salary in a descending manner, and I want to give this particular column name as a row number. Let's say I want to give this particular column as row number, sorry, maybe this is a SQL syntax, or we can give it as something like row number. Now you see there is a row number column created. There is no changes happen to the existing rows. There is another column got created which is a sequential integer column. Okay, there are 17 rows. So what are the use cases for this particular row number function? A lot of time when we need to assign a unique identifier to each row, or sometimes in the business cases when we need to select top 3 customers, top 5 products, or in those kind of scenarios when you need to select the top n rows for each group, then we can use the row number function. Now if I'm going to use a partition clause, as I told you, row number will create a unique identifier for each partition. That means now I have not used any partition clause, right? I have just used the row number and order by. So I can little bit trick this particular query to use a partition clause. Now let's say I'm going to use the partition by, let's say I want to partition on the employee name. Okay, or let's say I want to partition on the department number. Now if I run this particular query, you can see each department. Let's say I have department number 10, so it is creating a row for each department, 1 2 3 4. So 4 times department is there. So it is creating the row number for each partition. Now if you see, it is creating the row number for each department number, and that's basically used by my partition by clause. So basically, if I don't use partition by clause, it will take the entire data set as one partition. If I want to mention the partition by, it will basically create the row number for each partition. So let's say I want to delete the duplicate rows from my table. Say I have this EMP table and I can see there are lot of names which are duplicate. Like if you can see row number 14 and 15 are duplicate here, right? The Miller is there twice, and also I can see there is Blake and there is Blake. So they are also there twice. So I want to delete the duplicate employee name. So I have a scenario where I need to delete the duplicate employee name. How I can do that? Now, if I little bit twist this particular query and I write select star and row number I'm going to use on the employee name. Now you can see employee name which is duplicate is there twice, right? There are two different row number has been given, 1 and 2, because they are there twice. So for two employee similar employee number, we have row number 1 and 2. Otherwise, which are unique, the row number will be 1 only. But for the duplicates, as we are partitioning on the employee name, there will be row number 1, 2, 3 the times it is there in the table. So now it's very easy for me to delete, because what I'm going to do, I'm going to keep this inside one city. Let's say I create a city and I am giving the city as particular query, and then now if I'm going to delete from this particular city where Rn is equal to, sorry, greater than 1, that means where row number is more than 1, that will be a duplicate employee name. So we can delete that. Now let me to run this query. Okay, I wrote it wrongly. Our column name not is Rn, our column name is row number. So wherever we have a row number value more than 1, it will delete. More than 1, when we'll have more than 1, where there will be a duplicate employee name. So now if I run this query and then I'm going to check that particular table EMP, I can see my rows has become now 14 rows. Earlier I had 17 rows, and there is no Clark is no duplicate or Blake is not duplicate. So there is like no duplicate data. So this is the one of the uses of the row number function. So next Windows function today we'll discuss is rank function. Rank and dense rank. Okay. So as the name says, rank function is basically used to assign a rank for each row within a partition. So it will assign a rank, which is again kind of a numeric value for each row within a partition. And the problem with rank, if multiple rows have the same value in order by clause, they receive the same rank. And the next rank assigned will be the previous rank plus number of tied ranks. Okay, so this is little confusing. Let me to give you a proper example to make or clear this confusion. So what I told, rank will definitely create a rank or integer value for each rows in a partition, right? So we know how to create a rank. And the same way we can also do the dense rank. So dense rank is also going to create a rank for each partition in a table, right? So dense rank and rank does the same thing, but there is a slight difference. What is the difference? Rank will assign the same value for the multiple rows having the same value in the order by clause. Okay, and dense rank is also going to do the same thing, but rank, what will do, for the next rank assigned will be the previous rank plus the number of tied rows. But in dense rank, it is not the case. Dense rank will, do the next consecutive number for the next row. So what exactly that means? Let's say I have a table here. Let's say my business case is to I want to kind of like uh, for the rank. Let's say okay, we want to do the top ranking of the products by revenue. Let's say I have a business case. I want to do the ranking of products by revenue. Okay, I want to ranking of products by revenue. Let's say I have a table called product table and I have a table called sales table, from where I will get the revenue. Let's see my products table, how the products table is looking like. Okay, so let me to change my database. Okay. So let's see my products table. So this is the way my product table is looking like. So I have multiple products and the categories and their prices. And let's see my sales table. And this is the way my sales table is looking like. I have a revenue which total amount column is, let's say, is our revenue column. Now we want to do the ranking of product by revenue or total amount. So how we can do that? Let me to write a rank function, select star, then I'm going to use the rank function. So rank, again, the syntax is very much similar like row number, and here we can use the partition, or without partition also we can write a order by. So I am just giving a rank to entire data set. I'm not partitioning on any column basis right now. Let's say order by and my revenue column, which is total revenue, total amount, order by total amount, and I'm going to order by on a descending format. Okay, as ranking. Okay, and the same thing I'm going to also use for the dense rank, and we'll see the difference between a rank and dense rank now. Okay, same thing I'm going to do for the dense rank, and the column name will be, let's say we'll give it as a dense ranking. Okay, from my table is sales, and I'm going to do a join with my table products. Okay, now if you see, it has created two extra column, ranking and dense ranking. If you see, the columns which have similar total amount, okay, has been rank 1, and that's quite natural, right? Because they are making the same amount of revenue, so they should be the number 1 ranking products. Okay, let me do only take the product name rather than star, which will be a little bit convenient for us to understand this particular query. Okay, also I'll take the revenue column, total amount. Okay, now if you see this product name which has the similar revenue column or total amount column has been ranked 1, and that's quite natural. But if you see the ranking function for the next revenue item is coming as a rank 3, it is omitting 2, because as I told you, rank function what will do, the next ranking, whatever the value is there through order by clause, it will assign the number which will be the previous ranking plus number of time that number the similar value is repeated in the ranking. See here, 1 is repeated twice, so it will be 1 plus 2, which will be 3. Okay, So that's where ranking works. But dense rank does not do that. Dense rank will give the incremental ranking values. So if it is giving 1200 to 1200 product the same rank, the next value which is 700, it will give them as a rank 2, which is quite natural, and that's we expect. But rank does not do that. Rank will omit 2 here, because for it is 2 times here, the same value is there, and rank is given 1, then next value will be 1 plus 2. So this is the major difference between rank and dense rank. So you know now when to use ranking and when to use the dense ranking. Hope it clears your doubts. So let's go to the next Windows function. Let's talk about sum. Sum is again, it is a kind of aggregate function you guys have used by using the group by clause. We can also use sum function as a Windows function. And here we have to write sum over. Same way we can write, and we can use the sum function also as a Windows function. So where we need this sum function, let's say I have a business case where I need to find the running total of sales over time. Let's say I have this particular sales table, right? In this sales table, I want to find the running total of the sales over the time. Running total of sales over the time. So running total is what? Running total is like in the cumulative total. Let's say I have a sales. Let's say if I will write this particular, okay, let's see this sales table. I have a date column. Now let me to do a order by sell date. Okay. So now if you see, for each product there is a sell date, and I have first sales happened on the 1st of the January, second sale happened on the 5th of January, third sale happened on the 7th of January. Now total amount or the revenue for the 1st of January is 1200, 5th of January is 400, and 7th of January is 350 rupees. If I want to find out what is the total revenue by 7th of January, that is what the running total is. What is the total revenue for 7th of January will be the summation of this 1200 plus 400 plus 350. And if whenever you want to find out this kind of thing, you need the running total column. Okay, running total is nothing. Basically, it will give you the cumulative total over the particular time. So let's say how I will figure it out, this running total. Now I am going to use the sum Windows function. So let me write the query. Let's say select star, or we can take the maybe only product name. Let me to select. There are two tables we are going to discuss here. I am going to discuss sales and product. Otherwise, we can do the date wise. We can only use the sale table. Okay, and now I'll take the maybe date wise sale date, and now I'm going to use the daily sales. For daily sales, we just make the sum of total amount as, let's say, daily sales. Okay, and for running total I'm going to use the sum of total amount over, I'm not going to partition on anything, I'm going to only use the order by sell date on an ascending manner, and this will be our, let's say, running total column. Okay, now sorry, now let me to run this particular query. Oh, I have not used the group by. Okay, so group by has nothing to do with this second cell what we are using for running total. Group by is basically, as I want to find the aggregate of the total amount as a daily sales. That's why I'm using the group by. Otherwise, group by has nothing to do with that. Otherwise, we can do also one thing. We may not use this group by. We'll be, only create the total amount and we'll see our running total. Maybe, total sales we don't need. I just, let's take it out. Now, if you see, for sale date 1, total amount is 1200, running total is 1200. So 1st of January, we made a revenue of 1200. By 5th on the 5th of January, our total amount, our revenue is 400, but running total is 1600. Because if somebody asks on January 5, what is the total revenue we made till now, then what will be the total revenue? 1200 plus 400, which will be 1600. Again, 350 we made the revenue of 350 on 7th of January, so total revenue is 1950. So in this way, we are coming to know for any particular date, if you are taking by Jan 15th, what is my total revenue for the company? We are very confident that we created or we made a revenue of 5,170 rupees. So this way we are very clear. So running total is basically gives you YTD kind of values, or anytime you want to figure it out what is the sales till today, you can use a running total or cumulative total kind of columns to figure it out. And how to create that column is very easy by using Windows functions. We can do also without Windows functions, but that will be little tricky. I can show you in my another class how to do that. But here is a very easy way to do that is by using a Windows function. So our next Windows function is entile. Let's discuss about one more Windows function is entile. Okay. So entile, what it does? Entile, we give a parameter, and that parameter is a, let's say we give some kind of number we pass to this particular function. Entile divides the rows in an ordered partition into a specific number of groups. Basically, it will create a group, okay, and it will give the numbers in the same sequential manner for the each partition which is created on a particular order. So what is the business case? Let's say I want to create a bucket of products by revenue. Okay, so now if you see, I have a product table and I have a sales table, right? So, and our product also I have each category. I want to create a buckets of products by revenue. That means which products are giving me more revenue, then I can categorize them as a number one product. If which product is giving me less revenue, I can categorize accordingly. So my business requirement is, being in a retail company, I want to figure it out which product are A category, B category, or number one, number two product, from the revenue point of view. So whenever we want to create a bucket, let's say I want to create a bucket of products by revenue. So this is my requirement. So how to do that? I will create a or use a entile function. Let's say I'll take the product name as I want to create a bucket of products, and I want to join product table here. Is equal to p dot product id. Okay. Now, okay, sorry, products. So now we are able to create a join. I will use product name now, and now I want the bucket. I'll create a bucket. So before that, I will just use the total amount for our query purpose, and we use the entile function. So entile will take a parameter. Let's say I want to create the top 3 buckets. Okay, basically it will categorize for each product in each partition by 1, 2, 3. So how many partitions, like kind of category or bucket I want to create for each partition. So it will create that each partition. So entile Again, the usage is very easy. Entire order by. How I want to do that? I want to order by the revenue, right? So I will be doing the same thing. Total amount. Yes, I want to create on the descending format as my revenue bucket. Okay, I'll give it as my revenue bucket. Okay, so I have a product name, I have the product name, and I have a total amount. Then I have created this particular column entire. Now if you see the 1200, 700, 450, these are the giving me highest revenue, and I am categorizing them as one. See how it is doing. As I told you, totally we have 10 rows, and it is creating it has to create three buckets, one, two, three, right? That's the way we have given the bucket list as three. So for categorizing three, as it will entire product like 10 rows, it cannot be divided by three. So some row has some particular bucket will have a four rows, four, three, three. So it has to make it as a 10 rows total, right? So that's why it is creating the first four product and giving them as a revenue bucket of one. I mean, they are contributing more revenues to our sales. And the second headphones, office chair, and desk lamp, they are also second from the bucket list revenue point of view. They are also contributing significantly. And the last bucket, which is contributing less, is basically notebook, headphones, and notebook. Okay, there are notebook, there are two times. So this is where the bucket list is been created. This is very kind of useful when you work in any kind of retail, any kind of online, e-commerce kind of companies. Whenever you want to figure it out, which are which products are giving you more revenue or more margin, in those kind of things you can use this entire function. So next Windows function we use is lead and lag. Okay, so what we'll use the next Windows function is basically lag and lead. Let me to tell you a little bit about these functions. One is lag and another is lead. As the name says, guys, you know what lag does, right? Lag provides the access to a row at a physical offset before the current row within the same partition. Okay, what lag does? Lag provides access to a row at a physical offset before the current row within the same partition. That means it will allow you to retrieve the value of the previous row without doing any kind of joins. Okay, it will allow you to retrieve the value from the previous row. And lead is alternate to the lag or opposite of lag. It will allow to retrieve the value of the next row without doing any joins. Okay, so where to use? What is the use case of this lead and lag? So let's say the use case is let's say we want to compare the sales day by day. Like what was the day sales yesterday, what is the sales today, and with also sales with tomorrow. We want to compare the sales day by day. Let's say we want to compare the sales day by day. Okay, compare the sales day by day. So now I will use lead and lag function to do this. Okay. So how to do this lead and lag function? Let's say I have the now I want to do for each store. Okay. Now if you see my sales table, though I have the sales revenue for each store ID. Now I will, let's say, for each partition I'll do, or for each store I want to see what was the sales yesterday, what is the sales today, and I will figure it out. Okay, let's say I am going to use the store ID column here. Okay, I'm going to use store ID, and let's say we will know the sell date. What is the sell date? And I'm going to use the lead and lag function. Okay, lead function I will use Okay, I'm going to use lag of total revenue or total amount. Total amount, we'll figure it out over. Now I'll use the partition by store ID and order by, let's say, sell date. Okay, and I'll give this as the name will be, let's say, previous day sale. Okay, lag function, what it does, it will give me or access to the previous row, and lead function, what will do, it will give me the access to the next row. Okay, now if you see, and I'm going to use the total amount also here, okay, for better clarification. Okay, now let's say there is no point of joining the product table here. Okay, if you see, for store ID 1, January 1st, we made a revenue of 1200. What is the previous day sale? Nothing, because our the first sale happened on the 1st of January, right? So previous day sale is nothing. Oh, sorry, this is next day sale. For the lead, we'll give it as a next day sale. Okay, let me run the query again. Okay, so previous day sale is nothing because there is no row before it. This is the first row of that particular table when we are doing the order by on the sell date. And next day sale is 400, right? On the 5th of January, what is the total amount or total revenue we made? 400. So it is able to, in the first line only, I am able to read the next row. This is what the function of lead and lag. So whatever the row you are, let's say I am in the row number 3, where I made a revenue of 250, which is today's sales on the 10th of January. If I want to know the previous day sale, which is 400, and if I want to know the next row also, which is 200, I can know them. So lead and lag function are very useful whenever we want to compare the this year's sale with last year's sale, last week, if you want to compare this week's sale with last week's sale. So when that kind of comparisons is very easy to use lead and lag and do the comparison. Otherwise, we can do this also, without using Windows function, but that will be a little bit more complicated. But Windows functions makes it very, very easy. Okay. Then another function we'll discuss today is first and last. Okay, this is also highly used, first and last function. Okay, so this is like it's a very kind of straightforward question, right? Like first and last function is a very straightforward. That means, let's say I want to see the first and last sale for each product. Okay, I want to see the first and last sale for each product. Okay, I want to see first and last sale for each product. So here I can use the first value and last value function. So I have two functions here, first value and last value. First and last function, which is very useful. The first value and the last value. Okay, first value and the last value function, which is very useful. Okay, first value and last value. So let me to use them. So now I will have this, let's say I have product name and sale date. I'll take the product name also here, and I have a sale date, and I'll just do a inner join with product. Okay, and I'm going to use the first value and the last value. let's say I'm going to use the sell date, and here let's say we want to partition by product because we want to find out the fast and large sale for each product. So when we're talking about each product, that means I'm going to partition on the product ID. See, whenever you use like each department wise sales, like for each department or department wise sales, so what you do group by on the department number, right? So the same way when we're talking about for each product, we will be doing the partition by of the product and ordered by the, let's say, sell date as our first sold date. The same thing we can use for the last value. Okay, and here I'm going to partition on the product ID, and this will be our last sold date. Okay, now let us to run this particular query. Oh, product ID is ambiguous, sorry, it is there in both the table. Okay, now you see for laptop the first sold date is, oh sorry, oh, I did a mistake. I'm going to, okay, so we wanted to find the first and last sell date. So for product laptop the first sell date is January 1st and the last sell date is also January 1st. For second laptop there's another category. See, if you see here, the problem here is each value is there once in this table. That's why you are seeing the first sell date and last sell date as similar. But whenever in a real time you have millions of record, when one product is getting sold in everyday basis, that time this function will give you the first sell date of that particular product and the last sell date of that particular product. So in that kind of cases it will be very easy, but right now it may not be that easy because for you to understand this query, as we have one product and they have the one sell date, the first and last date is the similar. It may confuse you, but the usage is whenever you are a product, let's say Amazon is selling one product every day, so you want to see when that product first sell date was and what is the last sell date of that particular product. You can use the first value and the last value column, right? So in this way, we can use a lot of Windows functions. They are very useful, especially in data analysis. Windows functions are really useful. We also use in the, Windows. If you learn Windows functions, it's not only in SQL. If you are using PySpark, Databricks, you can use it also. Okay, and understand the concept of Windows functions. Windows function does not change the rows. It only create a new calculated or computed columns, and it uses basically it takes each it will create a partition and it will give the proper result. It is not going to change the rows, it's not going to change the table structure, so nothing to worry about it. And this is highly used in the data analysis environment. Hope you enjoyed this particular class. Thanks for attending neural tech analytics this session, and I'll come with a new session next time. Thank you guys.